Hello. Seems like this has been a while, but welcome back. Today we're talking about percent of change and how that applies to a lot of situations that you have in the real world. All right, when you buy things on sale or things like that, we often use percent of change. We're keeping track of investments. We a lot of times use percent of change to keep track of those. And a percent of change, right, is really what the amount of change is. That's the A in our formula compared to the original, the original amount. And then we have this less 100% because any percent change is going to be something that is moved from 100%. So if we have the amount of change, right, and here's our formula, A equals percent times base. If I divide both sides by B, let's see, can I do that easily? So says me. So I divide both of them by B, I get this formula here, A over B equals percent of change. So the amount of change divided by the original amount, that's the percent of change. Or if I don't have the change, if I just go from the new amount and the old amount, let's say that something was $10 and now it's $8. All right, well, the new amount is 8, all right, divided by the old amount, which was 10. And if I change that to percent, my math is correct, that's 80%. Well, the thing didn't change 80%. It started out at what percent? That's right, 100, right? The starting amount is 100% of the value always. So if the new amount is 80%, right, then we see that 80 minus 100, we subtract or less 100%, we find that that would become negative 20%. And clearly, if it started at 10 and went to 8, it went down 20%. So if we don't find the change, if we're just going off of the new amount and the old amount, we are going to find the percentage in our formula is going to be the percent, what the new amount is compared to the old amount. So we subtract 100 from that. If it was 10 and went to 12, then that would be 12 over new amount of 12, old amount of 10. That would be 1.2 or 120%. Well, again, if we subtract 100 from that, we found that that's a positive 20% or 20% increase in the percentage. Sometimes we're told what the percent increase is or the percent decrease in a lot of situations. And here's one. A markup is the percent of increase applied to the wholesale price of an item in order to generate a retail price. Now, if you own a store, let's say we own a Best Buy or something like that, we don't make the TVs, but we get them from Sony or Samsung or whoever at a particular price. And Sony is not selling the TVs to Best Buy the same price that they would sell, that Best Buy sells them to you. They mark it up a certain percentage, and then that becomes the retail price. And Sony does that because Sony makes the TVs. They don't want to have to sell one to Dave and one to Susie and one to they want to sell 1,000 TVs to me, who owns the Best Buy, and then let it be my business to sell them one at a time. So that's typically what a lot of the big companies do, is they will wholesale or sell a large quantity to stores, and then those are retail stores, they will mark it up a certain percentage. So to find a retail price, or that's the new amount, we should use our percent as a change from 100. So markup of 40%. So if I'm going to mark something up 40%, I wouldn't use 40% in my formula. The new price is really 100 plus 40 or 140% of the original price. So in my formula, I would use 1.4 or 140%. Okay, and so here's an example. Store owner buys tennis shoes for $28 from a company and wants to mark the inventory up 45%. Should sell his shoes for how much? So what we're looking for here is we're looking for the new amount. right, which would be the retail price. In this case, the base is the original amount, that's $28 that the store owner pays. And in this case, that's the wholesale price. All right, the percentage is going to be the markup of 45% on top of the 100%. So we're going to use 145% or 1.45 in our formula. And how much are we going to sell our shoes for? The retail amount, that is the new amount in this case. Because originally I'm the store owner, I bought the shoes for $28, and now I'm going to mark them up 45% to get a new price, and that I don't know, so that's going to be X. So in my formula, A equals percent times base. Again, I'm using the same formula I've been using, but now the percent is an increase of 45%, so I'm going to use 145%. And the original price is $28. And on my calculator, if I could do that, I get 40.6. So that would be $40.60. Now, that would be a 45% increase or markup. I may say that I want to offer the shoes for $39.95 instead. Now I would be having to make a decision that would be less than 45%. Do I want to do that, or do I want to mark them up even higher? All right. So again, the 45% we're using is going to be that increase. So we use 145% in the formula because it is an increase from 100%. Kind of the opposite of that is a discount or a percent off when something's on sale, right, or something's discounted. So a discount is an amount removed from a retail price to get a sale price. So here now retail price is not the new amount because we're not the store owner. If I'm the customer and I go in to the store, originally I see first price that I see would be the retail price. So if something's is $100 on the tag, that's the retail price. That would be, as the customer, that would be the base or the original amount that I see. If it is discounted, then a percentage is taken off from that. So when given a discount percent, let's say that it is 40% off. All right, we'll subtract that percentage from 100 to obtain the sale price percentage of the original. So if something is on sale for 40% off, the new amount is 60% of the original price. It's not 40%. 40% has been taken away from the original percent, which would be 100. Right? The original percentage is 100%. So the new amount A, the original price is B, and the percent is changed from 100 or subtracted. So if something's on sale for 40% off, I really want to find 60% of that original price. And that would be the sale price, what I would have to pay. Alright, so if I want to determine what the sale price is of a camera, originally priced $229, on sale for 30% off. So, just as everything, I can use the same formula for every problem in this chapter. If I know what I'm doing, A percent and base would be my identify step for ISMU. This original price $229, so that's the base. The original price or the retail price is $229. The percentage that I'm going to use, it's 30% off. I'm not going to use 30% here. I'm going to use 70%, so 0.7 or 0.70. And the new amount or the sale price is what I don't know. Here's my formula. A equals percent times base. X equals 0.7 times 229. And it's a simple matter of calculatorizing that to get 160.3 or $160.30. Now, can I use the fourth grade method, Mr. Bossert? What's the fourth grade method? Well, I can find 30%. In fourth grade, if your teacher gave you the same problem, you would find 30%, okay? So 0.3, you would have found 30% of 229 is 68.70, and you would have subtracted that from the original amount, right? And if I do that, I really will get 160.30. So can I take it and subtract it from the original? Yes. However, if you do not have the original price, if you don't have the base, you cannot use 30% in this problem. If they just give you the sale price, and we're going to have one of those later, you're not going to be able to use 30%. Oh, here we go. Later being right now. So what's the original price of a camera that was on sale for $209.99 if it was marked 40% off? Okay. And the reason I can't use 40% here is because the $209.99 is not 40% of anything. It's really 40% has been taken off from some amount that I don't know. All right, so I find 40% of some number that I don't know and then subtract it from that number that I don't know. Well, how do I do that? Well, you can't, except for it's 100 minus 40, or 60%. So the 209.99 is 60% of the original price. All right, that's not going well. So the new amount is 209.99. The percent is 100 minus 40, or 60%. So I'll use 0.60, 0.6. And the original amount, that's the thing that I don't know. So this is my problem now. Very simply, I'm going to divide by 0.60, 0.6. And that gives me 349.98. So that could have been my original price of the camera. Alright, so in summing up, things that would be an increase or added to 100%, something like tax, that's added onto. So if I use 6% tax, it's 6% on top of the 100% that of the purchase price. So you could use 106% or 1.06 as the percent in your formula. A tip is an increase. It's something that's added onto the amount. So a 20% tip, I would want to find 120% of the price, or I would use 1.2 in my formula. A markup as well. A markup is a percent that I added onto a wholesale price. So if something's 100% markup, I wouldn't use 100. I would actually use 100, which is the original percent, plus another 100 markup. I would use 200% or 2.0 in my formula. Or an account that earns interest, right? In the interest formula we did last time, 1 plus R, that's really 100% plus whatever the interest rate is. So 5% interest, I'm going to use 1 plus 0.05 or 1.05 in my formula. Something that would be a subtraction or a decrease from 100%, anything that's a discount or percent off. So something that's 25% off, I would use 100 minus 25 or 75% in my formula, 0.75. Something that lost value. So if something lost 10% per year for 5 years, I would use 100 minus 10 or 90%, 0.9 in my formula. And that would be a compounded loss, 10% per year. So it would be A equals P times 0.9 to the T. All right, we're going to do a couple examples. I want you to try this and hit pause and go ahead and the situation is that if a food bill comes to $15, there's 6% tax 20% tip. So the total amount that you'll leave for the meal. Now the tip and the tax, you're going to both of those figure those onto the food bill of $15. 15% of $15, 6% of $15. The hint is you can really add those together. So you really want to find it's a 21% increase. All right, pause that, do it, and come back. All right, so the new amount is the amount that I'm going to leave for the meal. That's the food bill with the increase of 21%. That's both of these added together. And a lot of times when you get a food bill, you may get it with the tax already added on. And some people put the tip on top of that amount. So you find the tax and then the tip. In theory, the tip should be on the food bill and not on the tax. You're not tipping on, what the government is adding on. You're tipping on the actual service that was rendered. But you could do it either way. The way that I'm choosing to show is the two of them added together. So both the 6% and the 15% are figured, their percentages of the $15, not 15% of 106% of 15. If you understand my meaning. All right, if I have a haircut that costs $21 and I want to leave 20% tip, what's my total cost going to be? Again, hit pause. Let's do that and come back. All right, so my new amount, or the total cost, is X. Percentage is 120%, so 1.2. Again, because I'm adding 20% onto the original 100% price. And my base, or my starting amount, is $21. I find that I get $25.20. Now again, because tip it's not a set thing, it's not a forced percentage, it's my choice. I may choose to only just give $25. Now if I do that, I should know that I'm giving a little less than 20%, maybe an 18% tip or something like that. But maybe if it makes it easy and I don't have to deal with coins, maybe I do it that way. Or maybe I give more because I want to be a big tipper. All right, that's up to you. But the 20% increase would give me to $25.20 if I want to give an exact 20% tip. Now, here's where we have a problem or an issue. Is when here's a retail price and a markup percentage. So I want to find the wholesale cost to the store for this particular item. The wholesale cost is the original amount. It's the first price involved that the store sees. It's a wholesale cost. This retail price here is the new amount for the store. So in this case, the new amount is the $50. The percentage is not 90 because it's marked up at 90%. So I would use 100 plus 90, or 1.90 as the markup percentage in the formula. And the original price, that's the thing that I don't know here. So this is going to be important for you to figure out the difference between those two. Here, if I use 90%, I can't use 90% and add it on to the original amount, because 90% of $50 is different than 90% of the original price here that I get. When I solve this formula, 50 divided by 1.9 is 5. 50 divided by 1.9, is 2631. 2632 if I round to the nearest penny. All right. So the original cost is 2632. If I find 90% of this number and add it onto this number, I'll get 50. But if I use 90% of 50, that's $45. If you subtract that away from that, you only have $5. The cost was $26.32, and then you increase that 90%. So again, you can't use 90% here because you don't have the original price, but you can use 190% because that's what $50 is, 190%, of the original price. All right, last example here for these notes. If something is on sale price $150 after a 25% off discount was being given. I want you to find the original retail price of the item. Here, the retail price is not the new amount. The retail price is the original amount, because now I'm viewing this as like the customer. I go into the store, I see an original price and a discount and a sale price. So I want to find out what the original price is. That's the retail in this case. And the new amount is the sale price of $150. So pause this, do that problem, and come back to check our answer. All right, so we see that the 25% off, I'm going to use 75%. Again, 100 minus 25, 75%. The new amount, 150, is 75% of the original. Divide by 0.75, I'm going to get 200. It's $200 was the original retail price. All right, thank you. Namaste. Shout out Block 3.